Hello. In this video, I'm going to introduce you to some of the fundamentals of trigonometry. So the word trigonometry is something that sometimes instills fear in people's hearts, mainly because it isn't a word that we use every day in regular language, but really its components are not scary at all. The first piece of this word is the trigonome, which really means triangle or three-sided shapes. And the metry part of this word means measurement. So the word trigonometry is a compound word that means triangle measurement. And it refers to a bunch of different rules and characteristics that are true for all triangles and for certain types of triangles. In all triangles, there is a characteristic that all of the angles, when you add them together, will add up to 180 degrees. That's true whether it's a right triangle or not. Okay, so this applies to all. And that rule applies to the triangles that we're going to be looking at today as well. In addition, we've seen in a previous video that if we're talking about right triangles in particular that have a 90-degree angle in them, there's another rule that can be used, which is Pythagorean Theorem. And that's the one that we've seen before. So those are two of the rules that we see in trigonometry. So if you know those, great, check those off your list. If not, you should check out the other videos that I've got about triangle geometry. Today we're not going to be talking about those two rules. We're going to be talking about the ratios. That occur in right triangles. So I've drawn some right triangles here to use as an example, and they're all the same, which is intentional. So I'm going to mark my 90-degree angle down here in the corner. And then I'm going to mark some of the vertices. That's the points where two sides meet. So just for consistency's sake, I'm going to call this lower left-hand angle A, B, and then the 90-degree angle I will call C. Okay, so the convention when you're naming shapes in geometry is you're going to use a capital letter for naming points, like this point and these 2 points. And then the side opposite that point will have the same letter but lowercase. So that would mean that this shorter leg here would be a lowercase a. Across from that angle B is going to be a lowercase b. And across from the angle C is going to be a lowercase c. Okay, and I've used A, B, and C just to make the link back to the Pythagorean theorem with a squared plus b squared equals c squared. We're talking about the length of these three sides. Well, that's great if I have two of the side lengths, I can find the third. Even if I had B and C, I could do a subtraction and then be able to find the length of A. But what the ratios are going to help us do is using side lengths, I can find the measure of the angles, A and B. I don't have to find C because I know it's a right angle based on this little marking that I've been given. if you're given a diagram and a problem to solve, and it isn't indicated with either words or with a symbol, then you can't assume, because diagrams aren't always to scale. In this case, I've marked it so you can, it's safe to assume that that's a 90-degree angle. Okay, so the first ratio that we're going to talk about is the sine ratio. And the sine ratio refers to, you have to choose an angle that is your reference angle. So I'm going to start with A, because that's the first letter in the alphabet. And then I'm looking at this as though I'm looking through binoculars or something like that, a sight. And as I look out from that angle, I see the side opposite, which is A, and that's going to bounce over here to the hypotenuse. So you can picture ricocheting off of this as though this is a mirror. So the sine of that angle A, from the point of view of that angle A, is A over C in this case. And the shorthand, usually if you were looking on your calculator, is just with 3 letters. That's for consistency, to make it fit on the little buttons. Okay. Okay, so in the case of these triangles that I've drawn here, A is 7 and B is 10. These are numbers that I chose those numbers initially when I drew the triangles out. And those are centimeter measures. Okay, so 10 and, oh, actually 7.5. Okay, so I can use my Pythagorean theorem to find the length of C if I want to use this sine ratio, because I need to know A and C. I know A, but I don't know C, so I'm going to use Pythagoras to get there. So I'm going to go 7.5 squared plus 10 squared gives me this value, 156.25, and then I'm going to go square root the answer, and I get 12.5. So I've just used Pythagorean theorem to figure out the length of C is 12.5. Okay, so now that I know what C is, I can use this sine ratio to figure out the angle. So sine A is 7.5 over 12.5. And this ratio, or this fraction, is a decimal value. 0.6. In order to figure out what the actual angle measure is, I'm going to have to undo that sine ratio. And that's where this calculator comes in handy. So for the buttons, sine, cosine, and tangent, your calculator is programmed. It has a table of values in its memory. And it has, in that table of values, it will have what is the value of an angle that produces a sine of 0.6. So I'm going to get the calculator to look into that table and seek the angle measure that's associated with the 0.6. I do that by saying second function sine of 0.6 and it tells me it's 36 point, I'll round that to 87. so based on this calculator, it's telling me that angle A is 36.87 degrees. Okay, let's look at the sine ratio for B. So we already figured out above that the value of A is 7.5, the value of B is 10, and the value of C is 12.5. So this time my reference angle is going to be B. So sine B. This time, if I look straight out from that reference angle, it's going to take me across to B. And C on the bottom. So sine B is 10 over 12.5. Again, that's a decimal. 0.8. Now I've got to get the calculator to go into the memory and retrieve what's the angle that generates a 0.8, that the sine of that angle generates a 0.8. So second function sine, it's telling it to look into that table, and it reads 53. So as a reminder, I'm using arc-sine, it's called. And that's 53.13. So if I double check here, remembering that all of the angles in a triangle should add up to 180 degrees, I can verify what I've just figured out here. So I have angle B is 53.13, angle A is 36.87, and if I put those both together, that gives me 90. This is just about rounding. So I've got 90 degrees plus the other 90 in the bottom right-hand corner. I've got 180.